him. Kill the guy now. You have to come. Hit him.
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you've been fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have you last semester.
We eat by pounds on you. Very stupid though. Yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.
Yeah, good afternoon, students. I am Mr. T.S. OGUNGBEMI from the Department of Chemistry at the ME College of Education. Yeah, I'm with a class of NC2 students today, and the course title is Nuclear Chemistry. And under this course, we'll be considering kinetic calculations of half-life. Happy view. Yeah, when we talk about the kinetic calculations of half-life, we'll first look at what we mean by radioactive decay. A radioactive decay followed a first-order reaction. For a single radioactive decay process, the number of nuclei disintegrating in a short period of time is proportional to the number present in that particular nucleus. Let us consider, for example, the decay process of a radioactive atom N. The atom is N. That is the atom. Atom N. We said it follows a first order reaction to give us the product. That means a single element is reacting to give us a product. That is a first order reaction. So undergoing some mathematical calculations, we have minus d of n all over n all over dt is equal to lambda n. And that is giving us the first equation, which is equation 1. Where our lambda is a first order constant. Lambda is a first order constant. So therefore we'll be having minus d of n all over n is equal to lambda dt. D of n all over n is equal to minus lambda dt. And that is the second equation, which is equation 2. So if this equation is being integrated, by parts, we have integral dt, then dt naught. So which is equal to d of n all over n to give us integral of when t is equal to 1 and when t is equal to 0 minus lambda dt. So what we are trying to do here is we are integrating this particular equation by parts. So when we have NT, and when we have N0 means at the initial stage, while NT means after some particular period of time. So we are integrating the N all over N, which is equal to, when T is equal to 1 here, and when T is equal to 0, minus lambda T. So this results at ln of NT all over N0, which is equal to minus lambda T. And that will give us the third equation. Or ln is the same thing as log of to base 10 of NT all over N0, which is equal to minus lambda T all over 2.303. So that means our lambda here is equal to minus 2.303 all over T log of NT all over N0. So that one is given as our equation 4. So from this equation 4, we can have another equation as equation 5. Lambda is equal to 2.303 all over T, which is log of log of N0 all over NT. We take that as our equation 5. So from here, we take this as the formula for calculating the lambda, which we refer to as first order constant. When it was minus 2.303 over T, it was NT all over N0. But when we change it from N0 over NT, the minus has disappeared. So we have lambda equals 2.303 all over T log of N0 all over NT. So when we have from equation 3, from our equation 3, that is this equation, we have our NT to be equal to N0 all over 2. You know, we call it half-life. At time t, we divide the initial by 2. That is what we mean by half-life. That means at half-life. That is at half-life. Our NT is always N0 divided by 2. So this implies that lambda T half is equal to ln of N0 divided by N0 all over 2, as we have it here. NT all over N0. Now, lambda T half is equal to ln of N0 over 1 multiplied by 2 over N0. So N0 will have cancelled the N0. So we have lambda T half is equal to ln 2. And ln 2 is the same thing as lambda T half there. So T half now, making T half the subject of the formula, is equal to ln 2 all over lambda. So we have T half to be equal to ln 2 over lambda, that is ln 2 is 0.693 all over lambda. So that is the formula for calculating the half-life. And we can as well calculate our lambda from this particular equation. So, or we can find our lambda there. Lambda is equal to 0.693 all over T half. Now, from this, now, our T is the time interval for the decay to take place. T is equal to time interval of decay. Our lambda is equal to first order rate constant, or we refer to it as decay constant. Decay constant. Decay constant. N0 is equal to number of atoms at the initial stage. That's the number of atoms at T is equal to 0. That is at the initial stage. Nt is equal to number of atoms at when T is equal to 1. I mean, when time is equal to, when T is equal to T. That means when time is equal to T. Then T half is equal to the half life of the first order reaction. So with this, we'll go into some little calculations as far as this is concerned. So the first question here is, a radioactive element has a half-life of 342.5 seconds. If 5.0 gram of the element weigh out at the beginning of an experiment, calculate the weight that remains after 173 seconds, assuming it is a first order decay constant. Now, looking at this question, we are given the half-life. T half is equal to 342.5 seconds. 5.0 gram of the element weighed out at the beginning. That means our N0 is equal to 5.0 gram. Calculate the weight that remains after 173 seconds. That means our T is equal to 173 seconds. And we are looking for Nt, which is unknown. So to calculate our Nt here, that means the mass that remain after 173 seconds. The first thing is to calculate the decay constant of the reaction. So first, calculate decay constant. So the first thing is to calculate the decay constant of the reaction. And if we can recall, we said T half is equal to 0.693 all over decay constant. That means the decay constant is equal to 0.693 all over half-life. So that means our decay constant is 0.693 all over. The half-life is 342.5 seconds. 342.5. So mathematically, if you manipulate this on your calculator, you have your lambda to be equal to 2.02 times 10 raised to power minus 3. That is your lambda there. So I am taking the lambda to be approximately to the nearest whole number. Lambda equals 2 times 10 raised to power minus 3. So that is my lambda there. So after calculating the lambda, we make use of lambda equals 2.303 all over t log of n naught all over nt. We are looking for our nt. And we've calculated our lambda. 2 times 10 raised to power minus 3 is equal to 2.303 all over, what is our t? Our t is 173 seconds. That's 173. Then log of n naught is 5 all over nt. Because we have been given our n naught to be 5. So with this, I have 2 times 10 raised to power minus 3 equals, you divide this by this. This 2.303 divided by 173, that's giving you 0.01346. 5 all over nt. So when you divide this, you have this. Yeah, don't forget we are looking for our nt. So from there, divide both sides by this. We divide both sides by this. That's 2 times 10 raised to the power minus 3 all over 0.01346 is equal to 0.01346 log of 5 over nt divided by 0.01346. So this will have cancelled this. So we have log of 5 over nt is equal to 2 times 10 raised to the power minus 3 all over 0.010346. Yeah. So you divide this by this again to get a single variable. So that means log of 5 over nt is equal to, when you divide this by this, it's giving you 0.1486. Now, mathematically, what do we do here? We take logarithm of both sides. When we take the logarithm of both sides here, we take the log to base 10. It is log to base 10. It's always logarithm to base 10. It's a natural logarithm. So we take the logarithm to base 10 of both sides. That means we're having 5 over nt is equal to log is equal to log arcsine 0.1486. So that means we are checking the second logarithm of this. That's the anti-logarithm. So it's giving us 5 over nt to be equal to, when you press second function log this, second function log this, it will give you 1.4080. Now, cross multiply this, 5 over nt. Why you cross multiply this? This will multiply this. 1.4080 nt is equal to 5. This will multiply this by cross multiplying. 1 will multiply 5. So you make n the subject of the formula now. Nt is equal to 5 divided by 1.4080. So your nt now, nt is going to be, when you divide that by 5, is giving you 3.55 gram. So that is going to be the nt. That means the amount in gram that remain after time t. So after that, yeah, there is a theoretical question here. And the answer is very simple and straightforward based on the explanation we have done in the past. It says when 50 gram and 25 gram of a radioactive element, 50 gram and 25 gram of a radioactive element N decayed, the radioactive element is N. So 50 gram and 25 gram of it decayed. It was found out that both are with the same half-life. 50 gram and 25 gram of an element N decayed. And at the end, we discover that they are with the same half-life. But when replaced with 50 gram of element M, when replaced with 50 gram of element M, the half-life obtained varied from the corresponding mass of element N. Explain. We use 50 gram and 25 gram of element N. We found that they have the same half-life after they have decayed. Now when we replace with another element N, we discover that the half-life vary. Why? The reason simply means that half-life for a particular nuclei element is constant regardless of disintegrating amount. Half-life for a particular nuclide element is constant. 50 gram is for element N. 25 gram is also for element N. So their half-life is constant. But when you replace with another element, definitely the half-life will be different. So that is the reason why that has happened there. Yeah, let's see another question. The activity of radioactive sample. The activity of a radioactive sample. The activity, that's question 2. The activity of a radioactive sample. Of a radioactive sample falls to 80%. Falls to 80% of the initial value. of the initial value in 5 years. In 5 years. What is the half-life of the sample? What is the half-life of the sample? That's the first question there. Question 2 there, calculate the time by which the activity, the time by which the activity will fall by 80%. Yeah. Yeah, this is this is an element. We said it fall from 80% of the initial value in 5 years. What is the half-life of the sample? Then we calculate the time by which the activity will fall by 80%. So question 1 there, half-life. The half-life is there. T half is equal to 0.693 all over lambda. But we don't know lambda. So to calculate the lambda, our lambda is equal to 2.303 all over T logarithm of N naught all over NT. That is our lambda. So we calculate lambda there. So we know that our A is equal to 100. It's always 100%. Since it's talking about percentage now, they said it fall by 80%. Then everything is 100%. So A is 100%. Yx, we have A minus x is equal to 20, is equal to 80%. And there, our T is equal to 5 years. So now, lambda now is equal to 2.303 all over 5 logarithm of N naught. That means this one stands for our N naught and this one stands for our NT. So N naught is 100 all over 80. Lambda is equal to, when you divide this by this, or better still, 2.303 all over 5 logarithm of 1.5. When you divide this by this, it's giving us 1.25. So that means lambda is equal to 2.303 multiplied by log of 1.25 all over 5. So when we find the logarithm of lambda now is equal to 0.22 3183.76 divided by 5. Now our lambda is equal to 4.46 times 10 raised to power minus 2 years. So that is our lambda. So lambda can now be substituted into this formula. We've obtained our lambda, we can substitute it into that formula now. And it's T we are looking for. The next question, T is equal to 2.303 over lambda logarithm of N naught all over NT. So T Our T is equal to 2.303 over lambda. And lambda is 4.46 times 10 raised to the power minus 2. Then log of 100 all over 20. So that's going to be 2.303 all over 4.46 times 10 raised to the power minus 2 logarithm of 5. 100 divided by 20 is 5. We obtain this 20 by subtracting 100 from 80. According to the question, it says calculate the time by which the activity will fall by 80%. It will fall by 80%. So that means our NTDR is going to be 100 minus 20. That is going to be, it will fall by 80. It means the gram that will remain is going to be 100 minus 80, which is going to be 20. So this now is equal to yeah. So when we divide this by this now, it's going to be T. Our T is equal to 2.303 multiplied by the log of 5 is 0.6990. Then everything divided by 4.46 times 10 raised to the power minus 20. So T is equal to, so when you multiply that out, it's giving us 1.609797 divided by 4.46 times 10 raised to the power minus 2. So we now divide this, our T is equal to 36.09 seconds. So that will be our T there. And it says, what is the half-life? The half-life. We have not calculated that. That is question 2 there, half-life. We know T half is equal to 0.693 all over lambda. That is our T half, 0.693 over lambda. That is our T half. So T half is equal to 0.693 divided by 4.46 times 10 raised to the power minus 2. So T half, when divided that by, when you divide that, we have T half to be equal to 15.54 years. So that is our T half there. Yeah. Before I will be rounding up, I pray God spares our life. We'll still meet next week again by the grace of God. You can mail me for an answer to this, for a solution to this question, if you have it. It says, the half-life of a radon is approximately 6 days. A tube containing 2 grams of radon was stored in a hospital for 12 days. How much radon remained in the tube? Thanks very much. See you once again next week. Goodbye.
Finish him. Kill the guy now. Rob the compound. Hit him. What's wrong with you?
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses like they're specially made for you.
I have you last semester.
We £5 on you. Very stupid though. Yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.